cells or something.
Okay, I will tell you. So the first type of redox is thermal decomposition. Okay. So what do you mean by thermal decomposition? Basically, when it is reducing, some element is getting reduced. For example, if I say AgO, what is Ag?
Ag
It's
is,
silver.
yeah.
Okay. So thermal decomposition means when you apply heat to this compound, what will happen? It will break. Silver will become in the elemental form, and oxygen will also become in its elemental form.
Okay.
So this is when you apply heat, it's called a thermal decomposition. Okay. Can you take out the values? I mean, can you take out which is the reducing or which is where is oxidation happening? Where is reduction happening? Can you take out that? The charges?
Okay. The when metals are in the elemental form, are they balanced?
Yes. So that means if they are in the elemental form, their charges has to be
0.
0. So you told me ki okay, this is 0 and this is
Yeah,
0.
that is 0 as well.
Okay. Now tell me here what is the charge on Ag on here Ag2O. What is the charge?
Ag2O. Wait, oxygen is normally 2 plus, right?
Not 2 plus, -2.
Oh, -2, okay. Then
Come on, give me the oxidation number on Ag.
yeah, Ag is 2 plus, right?
2 plus? Are you sure?
Oh wait, it's X.
Yeah, X. So what
X
will
and
be?
then it'd be 2x.
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 Okay.
Is that 2x minus 2
Very good. Equal to,
equals 0? And
right?
then,
So
so
X
x equals to 1.
plus 1. Correct?
Yeah, yeah.
So yes. So correct oxidation number you have taken out. So see. So what is happening, Swapna? Plus
Yeah.
1 to 0. It is oxidation number is reducing.
Reduced. Yeah.
That means it is a oxidation.
Yeah.
And oxygen is -2 to 0. That is oxidation number is increasing. That means this is reduction. Correct?
Wait, can I
Yes
just
or
say
no?
that again? Oxidation number is reducing.
So it is reduction.
I thought
From -2 it
when
is becoming 0. So it's going on the
I
positive side.
thought wait, I might be like confused or something, but I thought when oxidation number goes up, then it's oxidation.
Yes, correct. So right. That's correct. Oxidation and this is reduction. Super.
Okay.
Okay. Yes. So what is the reducing agent over here? Who is the reducing agent? Who's the
Reducing
oxidizing agent?
I just know them as the opposites of the reduction
Yes.
and oxidation. So the reducing agent is oxygen,
Superb. Oxygen.
and
Oxygen is your reducing agent and
oxidizing agent is silver.
silver. Understood this problem? Easy?
Yeah, yeah.
Wow. Now, Swapnip, I told you that I am teaching you types of redox reaction. This was one type, thermal. Why thermal? There is a compound, you heat it and it breaks. So this was some compound. It got break as soon as you gave the heat into silver and oxygen. Silver and oxygen got separated. The second type of redox reaction is displacement. Redox reaction. Most important. And there is a series which I will tell you to write. And this is where you were asking that question, now, which one replaces this one? Here that concept comes. Okay. So I will again explain you the same thing with the older example which we did just now. Zn plus HCl will give ZnCl2 plus H2. So you already know this is 0, this is plus 1, this is minus 1. This was how much? Plus 2, minus 1 and 0. Correct?
Yeah. Yeah. What does the RR stand for?
Redox reaction. Displacement redox reaction.
Okay.
Okay. So what happens? You told me, okay, ma'am, Zn is the oxidizing agent. Correct? Zinc is the oxidizing agent. You just now told me. Correct?
Wait, did I?
Not in this. When we were doing this example, no, you told me ki, see, oxidation. Zn is the oxidizing agent here. Right?
Oh, I thought it was the reducing agent.
Okay. So in this example, when I asked you ki which is the oxidation and which is the reduction, so you told me, okay, this is oxidation and reduction. And I asked you, okay, what is Zn? You told me it is an oxidizing agent. Correct. Now you are trying to understand, or you are trying to tell me basis on these. Okay. But this actually, what is happening, this Zn was alone, and what it is doing, it is replacing hydrogen from here and combining with chlorine, and hydrogen is getting removed. He threw him out. That means it is a displacement reaction. It displaced. Who displaced? Zinc. Who displaced whom? Hydrogen. Zinc displaced hydrogen. He removed hydrogen and he came with Zn. And that's how
it's when like one element in a compound is replaced by another element.
Yes, not replaced, displaced.
Okay, displaced.
Yes.
Okay, yeah.
Why displaced?
Because they still stay in the reaction.
Yes. Now, why am I focusing on all these things so much? Because it is not going to happen, Swapna, that every time something can replace something. No. There is a basically standard reduction potential series, which we call it, which you have to follow. You have to check whether this element will displace the compound or not, or whether this element can displace the other element in the compound. So how do we check it is now, now I will show it to you. So it is called standard
potential.
Yes. Reduction. Why reduction? Because it tells me what is the form of reduction. Potential series. What is potential? The potential to reduce a particular compound or a element.
Yeah, I was looking at this when I was doing my assignment.
Yes. So lithium. Come on. Lithium. Sodium.
I don't really know. I just looked at it.
No problem.
I can bring it up.
Lithium, sodium, barium, strontium, calcium, sodium, magnesium. Okay, so this is the way it is going. After magnesium will be aluminium, manganese, zinc. Okay, then I have, I think, chromium, After chromium is iron. After iron is cobalt, nickel. So this is going like this, okay? So after this is this. And after this, the third is after nickel is lead, Pb, see hydrogen. So zinc is at the top and hydrogen is at lesser place. That is why zinc was able to replace hydrogen. So basically in the series, it has to be below zinc. Then only it can replace. If hydrogen was above, then that reaction won't happen. Okay, I will tell you.
Yeah.
After hydrogen is Cu, Hg, Ag, Au. So after nickel, this comes. Okay, so you write it in one form. Don't write it like this. I don't have space. That's why I'm writing it like this. Okay.
So
yeah.
Wait, can you repeat that sentence that you said before so I can just write it down or like summarize it? Like it has to be above hydrogen.
Don't worry, we will be taking it more from here, but I will tell you. See, the element who will replace the other element has to be above that. Then only it will be replaced. Then only the reaction will take place. Otherwise, the reaction won't take place. So this is what am I saying? Which is going down.
Must have this a. Wait, isn't that like the? I forgot what it's called. Is it activation energy?
Okay, just give me 1 second if I can find this on Google, because what's happening is the space is less. So, it's lithium and all. See, lithium, potassium. See, Li, K, barium, calcium, sodium. See, Mg. See, you have to write it like this, one below the other. I have written it like this, but you have to write it like this. This one, these one by one. See? Like this. Few of them I have not written, few of them they have not written, but this is something which you need to write it like this. So basically, since if you observe carefully, this zinc, if you see, okay, wait, let me see. What I was trying to tell you was, see, zinc. Zinc is where it is above hydrogen. See, where is hydrogen? It is 1, 2, 3, 4, 5, 6. It is 6 below this. So zinc was able to replace hydrogen because it is in the, I mean, in this series, it is above the hydrogen. So that was the sentence I was trying to tell you. If the reaction will be like aluminium and calcium. So calcium can replace aluminium, but aluminium cannot replace calcium. Why? Because it is below the calcium in the series. That's what it meant to say. Okay.
Like, wait, what is this? What is this like technically measuring the series? The reactivity of the metal, right? Or like
yes, exactly. So when I'm talking about, see, this is what? This is tendency to get reduced. So basically, if I talk about, okay, let me take this here. So this is like tendency to get reduced. That means in this form, when you are going down, it is showing the reducing agent form. But what will happen for oxidation? Opposite. If I will ask you in the same reaction, ki, okay, oxidation, then you will have to see the lower one has to be the dominant one. It will go, oxidation will go this way, reduction will go this way, opposite. So you can remember one, you don't have to remember both, otherwise, and through one only you can see. So you have to remember this series. That's the most important part, because if you remember, then only you will be able to tell that the reaction will happen or not happen, and what is the question they have asked. Okay, so that way. So where were we? After AU, it is I think in between, I'm not sure, one I'm missing. It is, I guess, PB or PT. Just check this one. I'm not sure on this. And then we have iodine and bromium and chlorine, and last is fluorine. So the series is like this. So even if you see over here, see, why have they given it like this? Like when it is reducing, it is like this. When it is going oxidation, it is like this. Correct? So
Yeah.
that's why both arrows they have shown. Okay. So
Yeah.
in this series,
Wait,
if
how
we
do
talk
you use
about
the oxidation one?
which one?
Wait, can you go back to the picture, like the oxidation arrow?
This one?
Yeah. How do you use the oxidation arrow? Like if it's above.
Yes. So oxidation agent, see how they have made. In the reduction one, fluorine, they have put it at the top. But in the oxidation one, fluorine is at the last, like lithium. Here we were starting with what? We were starting with lithium here. It was at the top. And in the oxidation one, lithium is at the last.
Oh, okay.
Okay. It is like reverse.
Okay, that's fine.
You can compare. See, then is this thing. So they have just removed potassium. They have come directly to magnesium. So if you see here, after lithium, they've written magnesium. Here it is lithium, and then magnesium comes down. So it is opposite basically.
Yeah.
Correct. So if you talk about this is reducing and this is oxidation. This is reduction. Please put it reduction. And this is oxidation. Tendency to get reduced, tendency to get oxidized. Opposite. Okay? Shall we move? Let's do one example so you get more clarity on this. Okay, why are we discussing so much on this? Why is ma'am telling ki so much I have to learn? Okay. So according to this, which is the best reducing agent?
Lithium.
And which is the best oxidizing agent?
Fluorine.
Great. So now let us begin. So you can note down the series, or you can take a screenshot, or I will send it. Yes.
So does that mean in like oxidizing agent in like a oxidation reaction or whatever? Oxidizing agent would be in a reduction reaction, right?
Yes, you can say. So basically, if it is oxidation reaction, then it is a reducing agent. And if it is reduction, it is an oxidizing. So it's like, opposite you have to match like that.
Yeah.
Okay.
So if we're looking at oxidizing agents,
yeah,
then could they replace each other as well?
Yes, they can replace, but this time lower one will replace the upper one. In reducing agent, upper one will replace the lower one. That's the only difference.
Okay. But from the same series, right?
Yes, but from the same series. You have to refer the same series. For reducing, for reduction, upper has to replace the lower.
Yeah.
And for oxidation, lower has to replace the upper.
Okay, yeah, I understand.
That you have to remember. Okay?
Yeah.
But series will remain the same. One will go down, one will go up, like that.
Yeah.
Okay?
Yeah.
So let's move on to one example where you get more clarity. What are we trying to say? Why are we doing all this? And so on. So I give you one example. Zn plus CuSO4 will give you ZnSO4 plus Cu. What happened? Displacement. How can you say displacement happened? Because Zn has replaced copper from the SO4 solution and ZnSO4 is formed and copper is removed. Can you give me the charges on them quickly? What it will be? You'd know. These are in which form?
Elemental.
So this will become 0
Zero
and
and
this will
copper
be
is 0.
SO4
Isn't
charge
SO4
is how much? Yes.
isn't it like -1?
Which one?
SO4?
-1. Are you sure?
I think I'm thinking of like nitrate or something.
-2, dear. -2, not 1.
Okay. Yeah, I think I was thinking of something else.
Okay, so this whole is -2, so this will be +2.
Okay.
And obviously, this will also be +2. Correct?
Yeah.
So, can you tell me which is the oxidation and which is the reduction? Okay.
So oxidation is the zinc and reduction is the copper.
Super. So this is oxidation and copper is reduction. Okay. Will this reaction take place? Will this reaction take place? You have balanced, done everything. So that you will have to check using this. Is zinc above copper? Where is copper here?
Yeah, it is. It's in the third.
Copper? Copper is here.
Yeah.
So zinc is above copper. That means this
reaction will take place. Yeah.
This reaction will take place. Easy.
Yeah.
So I'll tell you the practical and example also, but I want to show you one more thing now. Now, can you tell me, will this reaction happen?
No.
Why?
Because copper is under zinc.
Yes, because copper is below the zinc. It will not happen. Okay. Now, where do you see the live example that you were doing now? That put 2 beakers, correct?
In a galvanic cell.
Yes, and in one you have say Zn and what is this one? CuSO4, correct? CuSO4, and there's this thing, and we have put a charge on it, correct? Yeah. So what will happen? Slowly, this zinc will go from here to here, and what will happen? It will replace copper and Zn. In the solution, what will come? In the solution, ZnSO4 will come, and on this, what will be left? Only copper. That's how zinc, that's how reduction or oxidation take place. Or you can say that your galvanic cells, how do they work? This is the funda overall. So this was the reason I wanted to start with your redox, because until and unless you know this standard reduction potential series, how will you operate any galvanic cell? They will give you like this. They will give you like Cu, and this solution will not happen when okay. Let me put it this way. If it is vice versa, okay. If it is vice versa, so I will say Cu is here, and here there is ZnSO4 in the solution, and this copper gets deposited here. We've put a charge, and then again this is the bar. So what will happen when copper will go now? It will not be able to replace this. Why? Because as per this, it is below. So the power of zinc is more. So what will happen? The solution, suppose it was pink below, it will remain pink only. Or if it was blue, it will remain blue only. You keep it for 24 hours, you keep it for 48 hours, no change. The practical thing which you will see, there will be no change in the solution. Nothing will happen. Why? Because this practically, theoretically, this cannot happen. The reaction cannot happen. But same thing, if you do it with zinc and you have CuSO4 and these plus the charge, and also if this was blue color, when zinc will come, the color of this will change. Maybe it will become light blue or maybe green or blue. I don't remember which color becomes which one. You can check once because I'm not that good in the color with this thing. And you will see the deposit. You will see the copper will be deposited over here. You can see it here. It will be a thick layer will be deposited. Why? Because zinc will replace from the solution copper, remove it, put it here, and it will, and you will see maybe after 5-10 minutes, if it was blue, it will become pink, or if it was red, it will become pink, something like that, or yellow. But some color change you will see here. In this, no. So that's how the practical applications you will see in the lab. Right? Okay. Let's do one more example. Ready?
Yeah.
Okay. So let us start. F2 plus Ki will give you Kf plus I. Okay. Which is oxidation and which is reduction?
Right.
I is
F2
iodine,
is
K is potassium, F is fluorine.
isn't F2 neutral?
Okay, come on, tell me the charges first of all. You know these two are in the...
Yeah, that's what I said. Isn't it? Yeah, okay.
Okay.
Yeah. So then fluorine. What's the charge of fluorine?
Fluorine is which group? Which group it belongs to?
Isn't it?
Halogen. Chlorine, bromine, fluorine.
Yeah. -1.
-1, +1. Iodine is also same. Chlorine, fluorine, bromine, iodine. So again -1 and +1.
Okay.
Correct?
Yeah.
So what is happening? This is becoming from 0 to -1. That means it is
Reduction.
superb. This is reduction. And what is this becoming? -1 to 0. That means it is
Oxidation, I mean.
very nice. You have taken out this. But my question was, will this reaction take place or not?
Just check. Table. Okay, so potassium.
Okay, potassium we will not see. We will only see the elements which are reducing and which are oxidizing. Chlorine and iodine only
fluorine.
You have to check.
Yeah.
No checking for potassium, okay?
Yeah. Fluorine, iodine. Well, this.
Sure.
This, what happens here? So fluorine. I don't think this would take place.
Correct. This will not take place. Why?
I didn't find iodine, but I'm pretty sure fluorine is the lowest.
Iodine is above and fluorine is below.
Yeah.
Obviously, this reaction won't happen. Yes, but if it was ulta, this way, I2 plus Kf will give you Ki plus F2. Then this reaction will happen.
Yeah.
Okay. So let me just put this, otherwise people will get confused here. It is like this. Okay, this reaction won't happen, this will happen. Correct? Why?
Yeah.
Because again, you take out the oxidation, take out the charges, 0, 0, +1, -1, check which is the reduction, which is the oxidation. And anyway, Swapnil, whenever you see fluorine in your, question, fluorine is the least one, like according to the reducing one. So as soon as you see fluorine first and then replacing, it will never happen. So these are simple tricks which you will get to follow when you practice at least 10, 20, 30 questions. Then you will say, Acha, this is fluorine in front. Oh, this won't happen.
Yeah.
1 mark question like that. But please remember this. This is the most important, most asked question. Even your galvanizing thing, even your practicals, they are all based on this. So please learn this if you can. If not, then the best way is at least remember few. Like there are, I think, so many. So maybe you can remember it like this. Lithium, the first group comes first. Then
Wait, I mean,
calcium. Yeah.
oh wait, no, this is not the same. This is something else. Okay. Don't
And you
worry
can
about
see
it.
halogen group comes at the last. See, in the last 4, they are iodine, bromine, chlorine, fluorine.
Oh, no.
So obviously, the halogen groups comes at the last. So you should remember it this way. If you can't remember all.
I mean, they give us standard potentials on a formula sheet.
No, they will not give you. Why will they
No,
give you?
but they do. It's the HSC formula sheet.
Oh, is it? If they are giving, it's good. In India, they don't give. If they are giving,
well,
then
yeah,
it's
they do. I just searched the HSC one for 2019 at least, and they have it.
okay. Then it's an added advantage for you. Super.
Yeah.
In our time, they never used to give, and India also they never used to give. Okay. So now one question for you. One question for you, which I will give you. Do you want it as a homework, or you want to do it now? What do you want to do?
I'll just do it now.
Okay. So the question is, can we stir a solution of NiSO4? That means nickel sulfate.
Yeah.
What is this? Nickel, and SO4 means sulfate.
Yeah.
Nickel sulfate with option A, with Zn spoon, and second with the silver spoon. You have to tell me the answers for both. Which reaction is feasible, which is not feasible, both are feasible, both are not feasible. Tell me what.
Wait, what does stir mean? Like just mean like
mix, stirring.
Mix. As in like
the
mix
yeah.
mix the Zn spoon into the nickel sulfate.
Nickel sulfate solution. So will this reaction happen? The color will change or not?
Okay, yeah.
And if
I
you
was
put
just
the
confused
silver
because
spoon,
I thought
yes.
stir meant like okay. Yeah, I get it.
Yeah.
Let me just see.
So how will you write the reactions? It will be very easy. Zn.
Yeah, Zn plus NiSO4.
And then what will happen?
2 on the product side, ZnSO4 plus Ni.
Second will be like this. So this is how they will not even give this. Only you will get a question like this. You have to make the reactions and all those things on your own.
Yeah.
So this will become AgSO. Actually, this is like this: Ag2SO4 plus Ni. So like this, you will get 2 reactions, and you have to tell me which one is feasible. Are both feasible? Are both not feasible?
Wait, how did you know it was Ag2?
Oh, Ag, what is the charge?
It's doesn't silver have a different charge to the rest of the?
No, +1. So This is
Yeah,
SO4
so
is -2, so you have to balance, no, +1 and minus, I mean -2 and +1. So that's why we made it 2.
oh, okay. Yeah.
That way. NI. Okay.
Wait.
So both are replacing AG and SN, ZN. Tell me the reduction, this reaction is feasible or not? This reaction is feasible or not?
Okay, so first one, zinc. Nickel is here. Zinc is here. The first reaction is working.
First one will happen. Okay.
Yeah.
So first you are saying the first reaction is feasible. Okay. So Swapnev says first reaction is feasible. Okay. What about the second one?
Second one, where is AG? AG. I don't think I have AG here. Can you go back to the oh no, I found AG. The second one won't work.
Second one won't
work.
Yes. So these are the right answers. The first reaction will happen. The first reaction is feasible and the second reaction is not feasible. And if you see the practical example, what happens? You are drinking something, you are eating something. If you put a silver spoon, does this happen that silver replaces your food materials and the color starts changing? No. But if you take a zinc spoon, no, that will all melt and come into your food and all those things. So that's why we have given this kind of example. So that's why people say, no, use silver spoons. Many people use that silver glass for drinking water and, silver. So this is the reason.
So, that means that technically if you use a spoon made out of magnesium,
yeah,
manganese or whatever this is, then that would be the best.
yes. But that is also not possible. Potassium, it comes in the air and it vanishes. It's so, light. So all these are like that. Sodium, potassium, you bring them in air, they will, like invisible, they will become like melt down like that. Have you seen salt in the rainy season? That salt, that powdery form, how it becomes melted, the wet and all. Why? All these reasons.
Yeah, I see.
So salt is what? Sodium only. Potassium only. Mostly sodium, potassium less. Okay. So two I have told you today. One was thermal decomposition. Second is most important, the displacement redox reaction. We will do two more, combination and disproportion redox reaction in the next class. Right?
Yeah.
Yes.
Yeah.
So now I think